What's going on, good peoples? Thank you for tuning in to another one of the sessions with the sensei. Today, we're going to be working on two-step equation word problems. Okay, all right, let's jump right into it. So for our example, okay, let's read through this. It says, a new one-year membership at Roswell Tennis Center costs $160. A registration fee of $28 is paid up front, and the rest is paid monthly. How much do new members pay each month? All right, so when we are dealing with two-step equation word problems, or what's also known as linear equation word problems, there are three things that we want to try to identify, okay? And that's our constant. We want to identify our independent, or excuse me, our dependent variable. And we also want to identify our total. Okay, so I'll try to use these three colors when we identify these. So for our constant, we're going to use this green color. For our dependent variable, we're going to use yellow. And then when we find our total, we're going to use orange. Okay, so all right, let's jump into this first one. So guys, when it starts this off and it says the membership costs $160. Okay, so a new one-year membership at Roswell Tennis Center costs $160. That is going to be our total. Okay. Then it says a registration fee of $28 is paid up front. Okay. Your constant. We identified that is whatever it is that you have to pay in the beginning or whatever it is that you have to start. Okay. So your constant can kind of be thought of as regardless of whatever is your total, whatever is your dependent variable, this is what you're going to have to pay regardless. Okay. So we'll make that $28. That'll be our constant. Okay, now for this next part, when you're dealing with your dependent variable, it's a couple of words that really give this away, and I'm gonna write them under it. So when you're dealing with your dependent variable, when you see the word each, when you see the word per, those are kind of giving you hints that that word will be your dependent variable. Okay, so for this one, when it says pay each month, okay, that is going to be our dependent variable. Okay, now they didn't give us a number, but if we use some of the context clues just in this question, at the beginning it says a new 1 year. So if we're dealing with 1 year and we're paying each month, let's just think, how many months are there in a year? It would be 12. Okay, so our dependent variable would be 12. So for this first part, it says, what is the important information we need to answer the question? Okay, we need to know those three things. Okay, we need to know what is our constant, we need to know what's our dependent variable, and we need our total. Okay, for this next part, for part B, it says, what will your variable represent? Okay, so we kind of already highlighted that part yellow. So our variable will be how much is paid per month. Okay. Now they're going to allow us to write our equation. Okay. Now, if you look underneath, it tells us exactly which parts of this equation it wants us to, or where it wants us to put. So it says the registration fee, which we identify as our constant. We're going to write that first, right? So we got 28. And then it says plus monthly costs per year. Okay. Monthly costs per year. Okay. So we're going to use 12. And for our variable, remember, variable can be interchanged. You can use X, you can use R, you can use M, and that's what we're going to use for this one. We're going to use M for month. And then our total would have been 160. Okay. Also, your constant and your dependent variable, those two numbers can be interchangeable, meaning even if I wrote this as 12M plus 28, it would be the same thing, equals 160. Okay, that would essentially be the same thing. Okay, so real quick, I'm going to take this off so I can move it down a little bit. So one more time, we're going to write out our equation. So we got 12M plus 28 equals 160. Okay, now that I have my equation, there's nothing else that can be combined, right? So I'm gonna make my four-way stop. Okay, now when I do that, we want to get m by itself, right? Want to get that variable by itself. But what is in the way immediately is this positive 28. So we're going to subtract 28 on this side. And then we're going to subtract 28 on this side. Okay, once I do that, I can bring this 12m down. And then equals. And then that would have given me 132. So now if I have 12m equals 132, we're solving for m, right? Remember, a number and a variable together is multiplication. To undo that, we're going to divide. Good job. Good job. Let's divide by 12. Divide by 12. So m equals 132 divided by 12, which would give us 11. Perfecto. Okay, not bad for the example. Let's see if we can dive into this first one. Okay, move the screen down some. All right, for number 2, Jasmine's cell phone company charges her $35 a month for phone service plus 50 cents for each text message. How many text messages does Jasmine send in a month if her bill was $52? All right, for this first part, for part A, 2A, it says write an equation using T for the number of text messages. Okay, so instead of just using M as we did in our last problem, when we identify a variable, we're going to use T. All right, let's find those three things: our constant, our dependent variable, and then we're going to find our total. Okay, so when I'm looking at this, what did I start off with? Okay, and that would be my constant. So when it says $35 a month for phone service, that means regardless of how many text messages that she sends, she has to pay that $35. So that's actually going to be our constant. Okay, now let's identify our dependent variable. Okay, remember, what's some of those words that we're looking for to find our dependent variable? Per, we have each. So for this part, when it says 50 cents for each text message, that lets us know that that's our dependent variable. Okay, last but not least, when we find in our total, okay, so when it says if her bill was $52, a lot of times when we're dealing with our total, it will use is, are, was, equals. Okay. All right, so we found those three things. Now let's plug them into our equation. Okay, so let's start with our constant. So we have 35. Uh-oh, let me fix that and make that black. It's a little easier to see. So we have 35, and then we're going to add 50 cents for each. Remember, that's letting us know to use our variable. So 0.50 x, and then we're going to say equals 52. And then, whoa, good catch. Y'all called me there. We're not going to say x. We're going to use t for our variable. So let's say 35 plus 0.50 t equals 52. Okay. All right. Now that we have that, let's see if we can solve that equation. So 35 plus 0.50 t equals 52. Four-way stop, since there's nothing that can be simplified. Okay, first thing that we want to do is get rid of this extra number. We want to get t by itself, but we need to get rid of this extra number first. So let's subtract 35 from both sides. Minus 35. Okay, then I will bring this 50 hundredths t down. And then 52 minus 35 is 17. Okay, I will have to divide both sides by 0.50, right, to isolate that variable by itself. All right, real quick, just in case you're not able to use a calculator, and if we're doing 17 and we're dividing that by 0.50, give you a second to write that down. Okay, keep in mind, when you are dividing a whole number by a decimal, the first thing that you want to do is move this decimal to the right and make sure that it's a whole number. So if I move 50 hundreds to the right two times, one, two, okay, now I have 50. However, the number 17 was a whole number. So the first thing I'm going to do is add a decimal so we can create it into a decimal number. From there, we're going to move it to the right two times. So that would be one, two. Boom. So there's our new decimal. Okay. In between these spaces we have here, we're going to add zeros. So now that's really 1,700 divided by 50. Okay, think. How many times can 50 go into 170? Or a little bit easier, think. How many times can 5 go into 17? 5, 10, 15, 20. So 4 is too big. The biggest that 5 can go into 17 is 3. So if I put a 3 above this 0 here, 3 times 5 is 15. We're just going to add a 0. So that would be 150. Okay, 7 minus 5 is 2. Keep this 0, and then we got to bring that last 0 down. Okay, so we got to think, was 200 divided by 50? Or how many times can 50 go into 200 without going over? That would be 4. Okay, 4 times 50 is 200. So that would have given us an answer of T equals 34. Not too bad, is it? How you feel about that? I messed my line up a little bit, but that's okay. Okay, that wasn't too bad. Okay, let's go to number 3. Caroline's Coffee Shop sells a refill mug for $8.95. Each refill costs $1.50. Last month, Sean spent $26.95 on a mug and refills. How many refills did he buy? Okay, so for 3A, started off by, let's try to see if we can write an equation, and we're going to use R for the number of refills for our variable, and then we'll solve. Okay, let's find those three things: our constant, a dependent variable, and our total. See if we can find those three things. Okay, so what would my constant be? Meaning, what would I automatically have to pay since we're dealing with money? Okay, so the refill mug is $8.95. That means you're going to have to pay that to start with. Okay, all right, there goes that word again. Each. Okay, each refill costs $1.50. So $1.50 would be our dependent variable. Okay. And then when it says she spent $26.95, that's her total. Okay. So we've been able to identify those three things. Let's see if we can put them into our equation. Okay. So if our constant was $8.95, we're going to add our dependent variable of $1.50. Let's use R for our variable as it asked us to do in the question. And then we're going to put that equal to $26.95. Okay, not bad at all. All right, so now let's write that again. 8.95 plus 150 R equals $26.95. Nothing else can be simplified for this one. So if I made my four-way stop, okay, want to get R by itself, but $8.95 is in the way. So if I subtract $8.95 on this side, subtract $8.95 on this side, that would have given me $1.50 R equals, and then $26.95 minus $8.95 would have given us 18. Okay. So if I'm trying to get that R by itself, remember, a number and a variable together, the only way you can put those together is to multiply. To undo them, let's divide. So we're going to divide by 1.50 or 1.5. Same thing. Divide by 1.5. All right, let's try that again just for some practice. So if I have 18, 1.5. Okay, remember, got to change that number, okay, that you're dividing by to a whole number. So if I move it to the right, if I move it to the right once, if I move it to the right once, that's going to give me 15. Okay, since I moved that to the right once, I would have to add a decimal, then I would have to move it to the right once. So that would really give me 180. Okay, so if I'm thinking 15 times 10, just estimating, right? 15 times 10 would give me 150, which is very close. Okay, 15 times 2 is 30. Okay, so if I have 150 plus 30, that would give me 180. So we could multiply 15 times 12. Okay, and that would give us 180. So R would equal 12. Okay, not bad, not bad. What y'all think about that? Okay, so one more on here I think that I want to try. And it had a little bit of geometry with it. Let's see. Yes, let's try this one for number 8. When I did this with a few of my classes, just the verbiage was a little bit different. So let's make sure we can identify those three things and write a good equation. All right, last one. The sum of the measures of the angles of all triangles is 180 degrees. If one angle of the triangle measures 45 degrees, the measure of the two angles is equal. What is the measure of the two other angles? So we got to write an equation and solve. All right, still, let's find those three things. Okay, we want to find our constant, our dependent variable, and our total. Okay, now if I'm looking at this, probably the first thing that comes or that kind of jumps out at you is the total when it says is 180 degrees. So let you know that's your total. Then it says if one angle of the triangle measures 45 degrees. Okay, so they're giving us one of them, right? So we can identify this as our constant. Okay, so this would be our constant, 45 degrees. Okay, now it says the measure of the other two angles is equal. Okay, so that would be our dependent variable. And I think I got my colors wrong, but you guys are y'all still with me. So 180, that is going to be our total. 45 is going to be our dependent variable. And then when it says two angles is equal, okay, that's going to let us know what our dependent variable is. So like I said, this one was a little bit more challenging, but pretty much still, as long as you're able to find those three things, it makes it a lot easier. Okay, so we start off with 45. Now it says two angles are equal, right? So we're going to make that 2A. And we're going to use A for angles. We're going to put that equal to 180. Okay. I hope that one made sense. But like I said, that's just incorporating a little bit of geometry into that and just understanding a little bit with the verbiage or the terminology. Okay, so once we've gotten that equation, let's solve for A. I'm gonna make my four-way stop. We want to get A by itself, but that 45 is in the way, right? So let's subtract 45 from this side. What I do to one side that equals, I have to do to the other. Okay, so I can bring my 2A down. Ooh, let's try that again. I can bring my 2A down. Then that would be equals what's 180 minus 45. That would have actually been 135. Okay. Now, if I'm dividing by 2, Okay, I want to isolate my variable, so I'm going to divide by 2. Okay, so I'm going to divide by 2 here. I'm going to divide by 2 here. Okay, so if I got 135 divided by 2, now that's an odd number divided by 2, so we know we're going to have a decimal, which don't panic. That's okay. All of your numbers do not have to equal whole numbers. 2 can go into 13 6 times. Okay, that would have given us 12. 13 minus 12 is 1. Bring that 5 down. Okay, you got to think, how many times can 2 go into 15? Okay, good. That would give us 7. 2 times 7 is 14. Now, if you wrote this as a fraction, meaning if you wrote 67 and 1/2, that would be fine. Okay. Me personally, as a teacher, I would accept that. However, I would tell you to try to put it as a decimal. Okay. So add a decimal here, add a decimal here. Okay. 2 can go into 10 5 times. So, like I said, 67.5, let's make a better 5. 67.5 and 67 and 1/2 is the same thing. So typically most teachers should take that. So that would give us A equals 67.5. Okay. How you feel about that one? Okay. Not bad. So just in general, I will be coming back to do some more problems in terms of the solving linear equations or solving multi-step problems. But like I said, the one of the first things you want to be able to do is identify those 3 things: your constant, your dependent variable, your total, and that just makes this process a lot easier. I appreciate you guys for tuning in, and I'll catch you soon for the next video. Peace.